In this video, we will discuss concept of derivative, which is denoted by dy by dx. So let's start our topic. Now let's understand derivative. Derivative, which is also called differential coefficient, is actually rate of change of a function. It is represented by or denoted by dy by dx. What does it mean? Dy by dx means change in y with respect to change in x. Now let us take some examples. Suppose a body is moving and its speed is changing, and we plot a relation between speed and time, and we get a relation like this, a straight line. At time t1, its speed is s1. At time t2, its speed is s2. So we have plotted time on x-axis and speed on y-axis. So dy by dx in this case will be change in speed upon change in time. Now, what will be the rate of change in this case? If this is A, drop a perpendicular in the dotted line. This is B and this is C. So rate of change in this case is going to be what is change in y, or we can say speed, that is BC. And what is change in x, that is time, which is AB. Now BC is S2 minus S1 and AB is T2 minus T1. So rate of change in this case will be S2 minus S1 upon T2 minus T1. Again, if this angle is theta, then what will be BC upon AC? That will be tan theta. So rate of change in this case is S2 minus S1 upon T2 minus T1, which is equal to tan theta, which is the slope of this straight line. Now you take any interval between T1 and T2, say an interval of T, and you find out what is the variation in speed for this time interval. For example, this variation is S. Now for this interval, what will be the rate of change? Rate of change will be S, this is T, so rate of change will be S upon T. And now S upon T will be equal to tan of this angle, and this angle will also be theta, which is equal to tan theta. So you can see that rate of change in this particular case is same throughout. The reason, I think you must be clear, most of you must be clear, that rate of change is same because it is a straight line. The variation is a straight line. The relation between speed and time is being depicted by a straight line. However, instead of variation being a straight line, which is there in this case, if it is like this curve, then how do we find the rate of change for this function? Now here some people may say it will be S2 minus S1 upon T2 minus T1. That is the average rate of change. But we want rate of change at any particular moment. So what do we do in this case? Now you can see that speed is increasing here, it is decreasing, it is increasing again, then it is decreasing, increasing, decreasing, and increasing. So the rate of change itself is changing. So how do we find rate of change for this function at any particular moment of time. So here comes the concept of derivative, and let me explain that. Now consider this curve of function y is equal to fx. Here I have taken a smooth curve. It can be any curve, it doesn't matter. I have taken it intentionally a smooth curve so that it is easy to explain it to you. And we take 2 points A and B on the curve which are extremely close. This is A and this is B. You will say that these points are not extremely close. Actually, they are extremely close. Just to explain them, I have drawn them like this. Otherwise, if I draw them extremely close, you will not be able to differentiate between those points. Now, the coordinates of A are x and y. So this is your x and this distance is your y. Since B is extremely close to A, that means with a small change in x and a small change in y, we will get B. Means we'll reach B. That means a small change in x, which is delta x. What is delta x? A small change in x. From here, if you draw a perpendicular, it will cut the curve at B, and this is going to be delta y. So you can see that a small change in x results in a small change in y, which is delta y. Now delta y can be positive or delta y can also be negative. Suppose the curve was like this, then delta y would have been negative. So it can be either way. That doesn't matter. Now just join AB via red line. Now if this is delta y and this is delta x, so this will also become delta x. So if this angle is theta, then delta y upon delta x will be equal to tan theta. And what is tan theta? That is slope of this red line. So tan theta is the slope of a red line, which is delta y upon delta x. Now what we do, we bring B slowly closer to A. Means we move B on the curve and we bring it close to A. Say B is at this point, we bring B here, 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 and here in such a manner that finally it is coinciding with A. It is nearly coinciding with A. So just see what will happen. As you bring P closer to A by moving it on the curve, now see this slope, that is tan theta, is changing. You can see the angle is changing. Bring it closer, more close, more close. Now as this delta x tends to 0, what do we mean by 10 to 10? 2 means it is very, 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 very close to 0. It is not 0, but extremely close to 0. So in that situation, what will happen? B will coincide with A. And then this red line will become the tangent at a point A. Now, the slope of the tangent which is delta y upon delta x, when delta x tends to 0, this is called dy upon dx. That means dy upon dx is equal to delta y upon delta x when delta x is tending to 0. So we write limit delta x tends to 0. So we write like this. I hope you have understood this. Now dy by dx is called derivative or differential coefficient. Also, dy by dx at any point is equal to the slope of the tangent at that point, because we have seen dy by dx at a is equal to slope of this red line. So at any point, if you want to find dy by dx, what you have to do, just draw a tangent and see what angle it makes with x-axis. Take the tan of that. That will be dy by dx. For example, if you are given a curve like this, y is equal to fx, and you are required to find dy by dx at this point P, what is required to be done? Just draw a tangent, see what angle it makes with x-axis. Now, just wait here. Here, which is the angle? One is this angle and the other is this angle also. Which one are you going to take? Are you going to take this or this angle? Actually, we have to take this angle because you have to start from x-axis and go in anti-clockwise direction like this. If you go in this direction, it will be clockwise. So this is not correct. So you have to take this angle. So if this angle is theta, then dy by dx is equal to tan theta. So I hope you have understood this. However, you will not be told to draw the curve and then draw the tangent at a particular point and find its slope, which is dy by dx. No. Normally the question which will be given will be like this. Say, for example, y is equal to 2x square plus 3x minus 5. And you will be asked, for example, find dy by dx at x is equal to 1. Now what will you do? You will differentiate this equation dy by dx and it will be 4x plus 3. And then you will find dy by dx at x is equal to 1. That means you will put the value of x as 1 here. 4 into 1 plus 3, which is equal to 7. What it means that if you are able to trace this curve and draw the tangent at x is equal to 1, then the slope of the tangent is 7. I hope you have understood this concept of derivative. That's all in this video. I hope you found it interesting. Thanks for watching. Have a nice day.